We take the test software of a brand tester as an example to illustrate the setting of current element test software. Open the tester test main interface. Open the general test 4v 3i interface. The test of current element can be divided into two ways: measuring the actual action value and detecting the action of 0.95 and 1.05 times the fixed value of the error boundary. To measure the actual action value, we first set the three-phase current to the initial value of 1A. It is expected to set the phase of fault. We can set the phase of voltage to 30 V. The test actual action value can be divided into automatic and semi-automatic modes. In automatic mode, we first check the automatic mode. Variable selection Iowa. Amplitude change. The change step can be selected according to the accuracy, such as 0.05 ampere. The change time shall consider the action time of the protection, which can be greater than the action time of the protection by 0.1 s or 0.2 s. The change start value and end value can be set according to the protection setting value. For example, if the setting value is 5 ampere, we can set the start value to 1A and the end value to 6 ampere. After setting, output the tester. The action feedback contact of the protection device is sent to the tester stops output, and finally record the protection action value. In semi-automatic mode, if automatic is not checked, it is semi-automatic mode. Select variable current IA, and the amplitude changes. The change step is set according to the accuracy requirements, such as 0.05A. Point the tester to start output, then point. The test will increase the current according to the set step until the protection action, and record the protection action value. Note, when manually increasing the current value, pay attention that the interval time is greater than the time of protection action. Detect the action of 0.95 and 1.05 times the fixed value of the error boundary according to the accuracy requirements of relay protection plus or minus 5%. If the setting value is 5A, then 0.95 times the setting value is 4.75A. We say that the IA current is set to 4.75A, the output current and the protection should be reliable. If the setting value is 5A, then 0.95 times the setting value is 4.75A. The output current and the protection should be reliable. Next, complete the test of low voltage components. Take the current protection section as an example. Check the current setting of 5 amps, the low voltage setting of 70 V, and the voltage is line voltage, and put into protection. In general experiment, the three-phase current is directly modified to 1.2 times the current setting value, 6 amps, to ensure reliable operation of current elements. The three-phase voltage is set to 57.7 V. Positive sequence. At the same time, set the variables to UA, UB, UC. Amplitude variation. The step size is set to 0.2 V. Press F2 to start the test. Click the down button. Until protection action. Record the phase voltage value during protection action in the tester, multiplied by 1.732. It is the low voltage action value. The action value can be compared with the fixed value and error analysis can be made. Next, complete the test of negative sequence voltage element. Take the current protection section I as an example. Check the current setting of 5 amps and the negative sequence voltage setting of 6V, and put into protection. In general experiment, we simulate the test under phase of fault. The phase of current is set to 1.2 times the fixed value of 6 amps. The B and C phases are set to a load current of 2 amps. Positive sequence. The three-phase voltages of UA, UB, and UC are all set to 57.7 V. Positive sequence. At the same time, set the voltage UA as a variable. Amplitude variation. In steps of 0.5 V. Press F2 output to run. Point down key. Manually decrease UA. Until protection action. Record the voltage value of phase at this time. According to the symmetrical component method, every 3V reduction of single-phase voltage, negative sequence voltage increases by 1 V. Therefore, the difference between the operating phase of voltage value and 57.7 divided by 3 is the operating value of negative sequence voltage. The action value can be compared with the fixed value and error analysis can be made. Next, complete the test of the directional element. Take current protection section I as an example. Check the current setting of 5 amps. Refer to the instructions. The maximum sensitive angle of the directional element is negative 30 degrees, and input directional circuit protection. Let's explain the scope of directional protection first. Take a phase directional element as an example. As shown in the figure, the maximum sensitive angle of the protection device is fixed at minus 30 degrees. When the power direction element adopts 90-degree wiring mode, operating range of phase a power direction element, among the angle between IA and UBC ranges from minus 120 degrees to 60 degrees. To facilitate testing, if UA is taken as the reference vector, that the action range of IA is between 30 degrees and minus 150 degrees. Next, in general test, we began to test the A-phase directional element. Set UA as fault phase. The voltage is 30 V. BC two-phase voltage is 57.7 V. Three-phase voltage positive phase sequence. Phase of current is fault current. The current amplitude is set to 6 amps. The angle is set to 35 degrees. And set law as a variable. Phase change. The step size is set to 0.5 degrees. Press F2 to run. Click the down button. Slowly decrease until protection action. Record action boundary value. Compare with the 30-degree boundary to analyze the error. Set phase of current to fault current again. The current amplitude is set to 6 amps. The angle is set to minus 155 degrees. And set IA as a variable. Phase change. The step size is set to 0.5 degrees. Press F2 to run. Click the Add button. Slowly increase. Until protection action. Record action boundary value. The error is compared with the negative 150-degree boundary. The above is our current element and low voltage element. Test methods for negative sequence voltage elements and directional elements. According to the difference of tester brand and model, the use settings of the software are different. Students can learn by reference.